Hello guys, welcome back. So in this video we are going to see another question of the LeetCode contest, right? So this is another question of the Sunday LeetCode, and we have given today 2D plane, right? You can say, and we have given the positive integers k also along with the 2D array, right? So 2D array is a queries, and you can see here, right? And it contains the following queries. So queries at you can say I having data x and y, right? Because it is 2D data, right? 2D array data. So we will build the obstacles at some coordinates value, and in this plane, right, in the xy coordinate, you can say it is guaranteed that there is no obstacle at this coordinate when this query is made. So after the first query, or each query, you can say you need to find the distance of kth nearest obstacle from the origin, and we have to return the integer array results from where array at I denotes the k nearest obstacle after I. We will add result at I equal to -1 if there are less than k obstacle, and we have to note that the infinity there are no obstacle anywhere. So the distance of obstacle at coordinate x and y from the origin is x plus y. You have to take the absolute value. Okay, so queries we have given, we have k we have given, and we have to return the output result. So how we are going to implement this? So you have to understand very carefully that we will create some priority queue. We'll keep the value in the map, right? In the hash map, you can say. Okay, or you can create a another sorted list also, and you can implement that, right? Means if you want to understand, first of all, let's suppose we'll create a priority queue, right? And we will use you can say as a max heap, right? As you can see here, right? And we use a max heap to store the closest k obstacles, right? So that the heap will ensure that the kth nearest obstacle is always the root of the heap, means the maximum element in the heap. So the heap will store the distances that we will calculate using this value, right? X plus y in the mode, right, from the origin. After adding this, right, for each queries, what we will do, we will make a for loop, and we'll go with each query, and we'll compute the Mahantam distance, right, from the origin, right? So how we are getting the Mahantam distance? Means maximum distance, math dot absolute value of x plus math dot absolute value of y. You will get the distance, right? And we will add this distance to the max heap. So you have to add this into max heap, as you can see here, right? Then what we will do, we have to maintain k nearest distances, and for that what we will do, if the if the heap contains more than k elements, we will remove from the farthest obstacle, you can say, right? And then that means the root of the heap node, you can say. So if the heap size exceed k, we will remove from the farthest obstacle the max element, you can say, like this, right? So if the heap size is equal to k, we will return the root of the heap, which is the kth nearest element, right? And for that, what we have to do, we will check if it is, if we have the less than k obstacles, we will return -1. Otherwise, we'll return the nearest kth nearest value we will return, and finally we'll return the result. Okay, so I hope you understand this video, and if you have any doubt, please ping me in the comment box, right? So if you'll talk if you want to understand more in the queries, right, let's suppose we have a example. Let's suppose if we'll take in the queries, if queries contains what some value, let's suppose 1 2 3 4 like that, if we'll have the elements, right? So after the first query, let's suppose if we'll go with here, right, let's after the first query, what we are getting, 3 and 4, right? So the distance 3 is less than k, right? Because k, let's suppose if we'll take let's k equal to 2, let's suppose in the example we have already given. So if k is 2, so here the first query, after the first query, what we are getting, 3. So the heap contains 3, means the distance 3 is less than k obstacle, so we'll return -1. You got my point? After the second query, what we have, let's suppose we will have 3 and 7, right? So if we have 3 and 7 or 2 or 3, whatever you can keep it here, don't worry. So after the second query, the heap contains, let's suppose 3 and 7, right? In this case, so distance 3 and 7 returns 7, right? It will return 7 because it have the second nearest, right? So we'll return 7 here. And let's suppose after the third query, if we have some element, so it contains what? 5, 3 or 7, 3 it contains, right? So we'll return what? 5. Why we will return the 5? Because the heap contains 5, 3 and 7. Okay, let's suppose after the fourth query, let's suppose, right, if we have some element is there, let's suppose minus 3 and 0 is there, minus 3 and 0 is there, and in the fourth one, let's suppose it was 2 and 3 was there, right? Like this. Then what we will do after the fourth one, what we will do here, we'll say it is minus 3 and 5, right? So in minus 3 and let's suppose 0, we'll take a 0. Okay, so after the last one, what we will have? 3, 3, 5, 7, because it will return what? 3, 3, 3, 5, 7. If we will have, we have to make a rearrangement. Okay, and then you will get the data. Okay, so we have to see the queries. Let's suppose we have to go through the queries, then we will check with the given k. So after the first query, if the heap contains the element, let's suppose 3, means distance 3 is less than k, will return -1. Otherwise we'll move to the next, means next we will go for the other queries. So similarly, you have to get and you have to put here, you have to poll it. If it is not equal to, if it is less than what? Obstacle k, you will return -1. Otherwise you will return the value. I want to say that, and then you will get the kth nearest obstacle queries. Okay, means always check with the k. If it is less than, it will return -1. Otherwise return the value and you will get the data. So if you observe the time complexity here, we are going with what? Insertion and removal, right? As you can see here, we are adding and we are pulling. We are adding here in the heap and we are returning. So for that we will get O of n will come, right, with the log k. Okay, where n is the number of queries, right, and k is the given elements, right? Next, let's suppose what about the space complexity? It will take O of k because of k elements we have, right? It will check with the value. So O of k, we can say it will store. Okay, thank you guys, thank you for watching this video. If you really like this video, please hit subscribe this channel so that you will get more videos like this.